Welcome, fellow travelers of the cosmos. Today, we embark on a journey. We explore a frontier as vast and mysterious as space itself, the world of artificial intelligence, our destination, a deeper understanding of intelligent machines. This journey is not just about lines of code or complex algorithms, it's about unraveling a story of human ingenuity, ambition, and the relentless pursuit of creating machines that can mimic and even surpass our own cognitive abilities. Before we launch into the future of AI, we must first look back. Understanding the history of AI is crucial. It allows us to appreciate the incredible strides we've made. It also helps us learn from past mistakes and navigate the ethical and societal implications of increasingly sophisticated AI systems. The story of AI is a testament to human curiosity. It's a story of daring to imagine a future where machines could think and learn like us. And as we'll see, it's a story that's still being written. Our journey begins in the 1950s, a time of post-war optimism and technological innovation. The world was recovering from the devastation of World War II, and there was a palpable sense of hope and possibility in the air. This era saw the birth of many groundbreaking ideas and technologies that would shape the future. From the advent of television to the development of the first commercial computers, the 1950s were a period of rapid progress and change. It's here that we meet Alan Turing, a British mathematician and codebreaker who helped lay the foundation for computer science and AI as we know it. Turing was a visionary, a man whose ideas were far ahead of his time. His work during the war, breaking the Enigma code, was just the beginning of his contributions to the field of computing. Turing's groundbreaking work went beyond simply building machines that could compute. He was interested in the very nature of intelligence itself. He wanted to understand if a machine could ever truly think, or if it was merely following a set of pre-programmed instructions. This question would become the driving force behind much of his later work. He dared to ask a profound question. Can machines think? This was not just a technical question, but a philosophical one as well. It challenged the very definition of what it means to be intelligent, to be conscious, to be human. Turing's question opened up a whole new field of inquiry, one that would attract some of the brightest minds of the 20th century. To answer this question, Turing proposed a test, now known as the Turing Test. The idea was simple yet profound. If a machine could engage in a conversation with a human and the human couldn't tell they were talking to a machine, then the machine could be said to be intelligent. This test was a way to operationalize the question of machine intelligence, to make it something that could be tested and measured. In this test, a human evaluator interacts with both a human and a machine through text-based communication. The evaluator's task is to determine which is which. If the evaluator can't reliably distinguish between the two, the machine is said to have passed the test, demonstrating a level of intelligence indistinguishable from a human. This was a radical idea at the time, one that challenged the prevailing notions of what machines could and couldn't do. If the evaluator can't reliably distinguish between the two, the machine is said to have passed the test, demonstrating a level of intelligence indistinguishable from a human. This concept was revolutionary, as it suggested that machines could potentially possess human-like intelligence. It opened up new possibilities for what machines could achieve and how they could be integrated into society. The Turing Test, while controversial, sparked decades of debate and research into the nature of intelligence and the potential of AI. It forced scientists, philosophers, and engineers to grapple with fundamental questions about the mind, consciousness, and the future of technology. Turing's legacy lives on in the ongoing quest to create machines that can think, learn, and perhaps one day even feel. Fueled by Turing's vision, the 1960s and 70s witnessed an explosion of excitement and progress in AI. Researchers were inspired by the potential of creating machines that could think and learn like humans. This period was marked by a sense of boundless possibility and innovation. This era gave birth to the first AI programs capable of playing checkers, solving mathematical problems, and performing tasks that were previously thought to be the exclusive domain of human intelligence. These early programs demonstrated that machines could be programmed to follow complex rules and make decisions based on those rules, and even understanding simple, natural language instructions. This was a significant breakthrough as it opened the door to the possibility of machines that could interact with humans in a more natural and intuitive way. One notable achievement was ELIZA, a program developed by Joseph Weizenbaum at MIT. ELIZA was designed to simulate human conversation, and it was one of the first programs to demonstrate the potential of natural language processing. ELIZA could simulate human conversation, particularly that of a Rogerian psychotherapist, by using pattern matching and substitution methodology. It was able to give responses that seemed empathetic and understanding, which surprised many users and researchers alike, and surprised many with its seemingly empathetic responses. People were amazed at how a machine could mimic human conversation so convincingly, even though it was simply following a set of programmed rules. Despite these early successes, AI researchers soon encountered significant challenges. Limited computing power, a lack of data, and the sheer complexity of human cognition proved to be formidable obstacles. The hardware of the time was not advanced enough to support the ambitious goals of AI research, and the sheer complexity of human cognition proved to be formidable obstacles. Researchers realized that understanding and replicating human thought processes was far more difficult than they had initially anticipated. The limitations of the technology available at the time made it hard to achieve significant progress. The initial optimism of this era gave way to a period known as the AI winter, characterized by reduced funding and tempered expectations. Many projects were abandoned, and the field of AI research faced a significant slowdown, characterized by reduced funding and tempered expectations. The AI winter was a time of reflection and reassessment for the field. Researchers had to come to terms with the limitations of their current approaches and rethink their strategies for achieving artificial intelligence. Section 5: The rise of expert systems in the 1980s. The 1980s saw a resurgence of interest in AI, driven in part by the rise of expert systems. These systems were a significant leap forward in the field of artificial intelligence, capturing the imagination of both researchers and businesses alike. Expert systems were designed to mimic the decision-making abilities of human experts in specific domains, such as medical diagnosis or financial analysis. They were particularly useful in areas where the expertise was scarce or expensive, providing a cost-effective alternative to human experts. These systems relied on a knowledge base of facts and rules, carefully curated by human experts, and used an inference engine to answer questions and provide recommendations. The knowledge base was essentially a repository of information, while the inference engine applied logical rules to this information to derive conclusions. While expert systems proved valuable in certain niche applications, they were limited by their reliance on explicit, hand-coded knowledge and their inability to learn from new data. This meant that they could not adapt to new situations or improve their performance over time, which was a significant drawback. Despite these limitations, expert systems laid the groundwork for future advancements in AI, highlighting both the potential and the challenges of creating intelligent machines. Section 6: Machine Learning takes center stage. 2000s. As we entered the 21st century, a paradigm shift occurred in the field of AI, the rise of machine learning. Unlike expert systems, which relied on pre-programmed rules, machine learning algorithms could learn from data, identifying patterns, and making predictions without explicit instructions. This shift was fueled by the exponential growth of data, the increasing availability of computing power, and the development of new algorithms. Machine learning algorithms such as support vector machines and random forests achieved impressive results in areas like image recognition, spam filtering, and recommendation systems. Section 7: Deep Learning and AI Applications, 2010s-present. The 2010s ushered in the era of deep learning, a subfield of machine learning inspired by the structure and function of the human brain. Deep learning algorithms use artificial neural networks with multiple layers to process vast amounts of data, learning complex representations and achieving state-of-the-art performance in areas like computer vision, natural language processing, and gameplay. Deep learning has revolutionized AI, powering applications like self-driving cars, virtual assistants, and personalized medicine. This era is marked by the widespread adoption of AI across industries and the increasing integration of AI into our daily lives. Section 8. The enduring influence of AI's history. As we've seen, the history of AI is a tapestry woven from both triumphs and setbacks. From the early days of Turing's vision to the modern age of deep learning, each era has built upon the successes and learned from the challenges of its predecessors. This journey through AI's past reveals a profound truth. The quest to create intelligent machines is an ongoing adventure, full of promise and uncertainty. Understanding this history is not just about looking back. It's about equipping ourselves to shape the future of AI in a responsible and beneficial way. Section 9. Looking ahead, how AI works. And so our journey through the history of AI comes to an end, but the adventure is far from over. We've explored the milestones, the breakthroughs, and the enduring influence of AI's past. But a crucial question remains: how do these intelligent machines actually work? Join us next time as we dive into the fascinating world of AI's inner workings, exploring the algorithms, the data, and the computational magic that brings these intelligent machines to life.